Secondary succession within the surrounding forests of Point Pleasant Park, presented by Parushi Kapoor, Rohit Shankla, and Sharon Musi-Menta.
Ecological succession is a gradual and predictable change in community structure following the disturbance. In forests, a secondary succession occurs when an event removes vegetation but leaves the soil intact, allowing new species to establish over time. Point Pleasant Park, located in Halifax, provides a clear and powerful example of this process. On September 29, 2003, Hurricane Joan struck Nova Scotia with sustained winds of 151 km per hour and caused the loss of approximately 70% of the park's trees. Much of the forest was an even-aged, planted evergreen strand rooted in shallow glacial soils, making it especially vulnerable to uprooting and withdrawal. Studying the long-term recovery of this urban Acadian forest is important for understanding how tree communities respond to severe disturbance, how diversity changes through time, and how future forest structure may develop. The forests also hold a cultural and historical significance to Mi'kmaq Nation, whose knowledge system emphasizes relationships with land, ecosystem renewals, and resilience. By analyzing the changes in tree density, species composition, and community metrics across 6 permanent sampling sites from 2004 to 2025. Our project aims to examine how the forest is regenerating and how its community dynamics compare to ecological theory on secondary succession. The framework allows us to explore which species are becoming dominant, how diversity is shifting, and how the park's future trajectory. Hypothesis: if secondary succession is occurring in Point Pleasant Park, then species richness will increase over the time as new species establish following the Hurricane Joan.
We studied the effects of the hurricane at Point Pleasant Park to see if secondary succession had taken place. We had 6 study sites that were measured 20 by 20 centimeters. We used study site 1. These sites were chosen because of the hurricane's disturbance it left on this area. We collected data on 2 variables, the total population density and the density breast height, to compare them to the data collected from 2003. Trees equal to or greater than 2.5 centimeters in diameter for breast height and are 4.5 feet off the ground were measured. Ground flora was measured in a set quadrant by throwing an object to initiate measurement with a smaller wooden quadrant, which was used to calculate the percent coverage of each identified species. Linear regression was performed using R to determine the statistical variables, which helped us observe secondary succession over the years. Results. In this experiment, we are observing if secondary succession has occurred in study site 1 of Point Pleasant Park by having an increase in new species. We performed a linear regression in Figure 1 to view an increase in new species. The total population density of a new species has a positive relationship in 2025, where it has increased compared to 2003, where the population is lower. Figure 1 shows an increase in trend line and an equation and R squared indicating the forest is denser than it was in the early 2000s. The p-value being significant and having a high R squared value indicates that there is an increase in new species in the area, which confirms the hypothesis as succession has proven to take place in the study site 1. The forest community has increased in diversity, which allows us to fail to reject our hypothesis that secondary succession has occurred in Point Pleasant Park as a new species has recolonized the area. Figure 2 has a positive regression line leading to the increasing density in 2005 compared to 2003. This can occur because of the soil. While the soil was left in ruin after the hurricane as it was damaged with erosion, trashed, and had broken trees were covering the soil, the removal of such debris creates more surface area. Just as Burley in 2008 came to discover that the nitrite levels of Point Pleasant Park compared to the reference site, the increased levels of microbial activity and nitrogen mineralization after the canopy opening. The soil regenerates itself and gains back nutrients to support the tree, which allows new species to come and recolonize Point Pleasant Park, allowing competition, which increases the abundancy of the study site. We can predict that the forest over time will reach a reduction in tree density. The habitat being filled with new species and competition will arise between them, where things such as light and nutrients will lead to new trees thinning out, leaving the population to overall hit an equilibrium after the time with species in the area.
We examined changes within red spruce density, number of individuals per 400 meters squared across various testing sites across Point Pleasant Park from 2004 to 2025. The density of red spruce increased from values of 1 to 7 individuals within 2004 to 2 to 23 individuals present within 2025. All recorded values fall within the ecologically realistic regeneration levels for case-selected conifers. The spread of points across the various years outlines a high natural rate of change. Additionally, due to this range, the regression analysis suggests that the correlation between time and density were proportional, with a positive increase. However, the overall correlation, although statistically significant, was weak with an R-square value of 0.13. Red maple density values were also collected across the various testing sites within Point Pleasant Park. Red maple was absent from all tested locations within 2004, but rapidly increased thereafter, ranging from 1 to 78 individuals per 400 meters squared by 2025. This large range is ecologically credible for pioneer species experiencing a post-disturbance release. When conducting the linear regression analysis, it was found that red maple were also increasing in density in relation to time. However, the rate that the increase occurred was significantly greater than that of red spruce, with the slope of the linear regression being approximately 6.5 times greater. Although the observed correlation was statistically significant, it was also weak due to the R-square value of 0.14. The contrasting density patterns and trend lines observed for red spruce and red maple reflect classic post-disturbance secondary successions as described by Nelly et al. In 2004 and Keyes in 2019. Nelly 2004 documented that Point Pleasant Park was originally dominated by mature red spruce and white pine stands, typically near climax conifer forest prior to Hurricane 1. The storm acted as a major stand-initiating disturbance, producing high light, open soil conditions ideal for early successional hardwoods. Keyes 2019 later observed that in 2017 to 2018, approximately 74% of the park had transitioned into vegetation types dominated by species such as red maple and white birch. These findings directly supported the strong positive red maple trendline in our dataset, which reflects rapid colonization typical of disturbance-responsive hardwoods. Meanwhile, the weaker red spruce trendline aligns with the slow recovery expected for shade-tolerant late successional conifers. The rise of both species through time supports the hypothesis that species richness increases during secondary succession as new species establish after disturbance. Overall, the data and literature together indicate that current red maple dominance represents an intermediate successional stage, whereas the gradual increase in red spruce points towards a long-term shift back to a red spruce white pine climax forest.
The regression equations indicates a strong positive relationship between year and richness. The significant p-value shows that species richness increased steadily over time. Although species richness may vary slightly among sites due to difference in soil depth, microsite conditions, and sampling in FIT's 400 meter square plots that may miss rare species, the long-term trend is very strong. The high R-square value and extremely significant p-value indicates that this increase in richness is reliable and accurately reflects ongoing succession in Point Pleasant Park. In Figure 5, the species richness of Point Pleasant Park increased significantly from 2004 to 2025, showing the strong positive regression relationship. Species richness measured how many different species are present in the community, and its increase indicates that more species have successfully established after Hurricane Juan. This supports the ethological's expectations that during secondary succession, canopy opening, increased sunlight, and reduced competition allows new species, including pioneer species and later shade-tolerant species, to colonize the area. This pattern is consistent with previous findings by Burley et al., who observed the nutrient changes, canopy openings, and increased nitrogen mineralization after disturbance promoted species establishment in regenerating forests. As the Etherean forest continues to mature, richness is predicted to eventually stabilize or slightly decline as competition increases and later succession species dominate. Overall, the upward trend demonstrates that the forest community is recovering, diversifying, and progressing through the intermediate stage of secondary succession.
Increases in total density, species richness, and contrasting trajectories of red maple and red spruce. Species richness shows a strong long-term rise, and total density continues to climb as more individuals establish. Red maple, a fast-growing pioneer hardwood, has expanded rapidly since 2004 and now dominates most sites, while red spruce, a late successional shade-tolerant species, is increasing slowly but steadily. This mixture of dominant pioneer species and gradually recovering late successional conifers is characteristic of a mid-successional Acadian forest. As the park continues towards a mature near-climax state, increasing canopy closure will reduce sunlight and intensify competition. Over time, we expect the red maple recruitment to slow while red spruce becomes more successful. eventually shifting to a community towards the classic late successional red spruce and white pine forest typical of the region. Because this is an urban park, the successional pathway is shaped by ongoing disturbance. First, soil compaction from heavy foot traffic makes it harder for slow-growing conifers like red spruce to regenerate, helping explain their weaker increase. Second, urban edges promote disturbance-tolerant species and invasive plants, which give fast-growing hardwoods like red maple an even stronger advantage. Incorporating Mi'kmaq knowledge and teachings, especially principles of Netaglumic, which emphasize balance, regeneration, and long-term ecosystem health, can support this recovery. Practices such as protecting conifers, regenerating microsites, managing invasive species, and fostering natural processes like nurse log development can help guide the forest towards a resilient, mature Acadian community. Overall, the data showed that Point Pleasant Park is recovering strongly from Hurricane Juan and is progressing through the middle stages of succession towards a long-term forest structure.
A thank you to Joanne Zigris, the DMs, for providing the graphs and data analysis. We would like to acknowledge the land during the site visit as the Mi'kmaqi and the ancestral and ceded territory of the Mi'kmaq people.
References.